All right, students, welcome to lesson 12, linear equations in two variables. Now we've been doing these equations in two variables for count them, 3 lessons now, and we're not done yet. So let's get going. Use a table to find solutions to a given linear equation and plot the solutions on a coordinate plane. So we're going to create a table and then plot them, so we're going to graph them, okay? A linear equation in two variables is in the standard form when it's in ax plus by equals c for numbers a, b, and c, and a and b are not 0, okay? The numbers a, b, and c are called constants, and the solution to a linear equation in two variables is all the ordered pairs x and y that make up a given equation true, all right? So solutions can be found by fixing a number for x and solving for y, or fixing a number for y and solving for x, right? So we got two variables. You can't solve for two variables unless you know one of those. When we first started solving equations, we had x plus something equals a number, or whatever. So then we solved by combining, like we distributed, combined like terms, add and subtract to move all the x's on one side, the numbers on the other side, and then divided to figure out how much it is for one x. If we have two variables, we can't do that because we'll have two different variables. So what we do is we say, I'm going to say this is the number for this variable, and then I'm going to solve for the other variable. So let's see how that works. Let's say Emily tells you she scored 32 points in a basketball game. Write down all the possible ways she could have scored 32 with only 2 and 3 point baskets. Use the table below to organize your work, right? So to figure this out, let's start with 2-point shots, right? If she scored 32 points and 2-point shots, that would be 16 2-point shots, right? 16 times 2 is 32. And so she made 0 3-point shots. If she only made 15 shots, that would be 30 points. And then a 3-point shot plus 30 plus 3 is 33 points. So she couldn't have done 15 2-point shots. She did 14 2-point shots. That would be 28 points. 32 minus 28 is 5. So she couldn't have done, there's no way of getting 5 points on 3-point shots. So she couldn't have done that. If she did 13 2-point shots, that'd be 26. 32 minus 26 is 6. So that would be 2 2-point shots. So she get to 13 2-point shots and 2 3-point shots. And we can go on like that. So if she did 10 of these, that would be 10 times 2 is 20. So then she did 12 in 3-point shots, and 4 times 3 is 12. So she did 3 3-point shots, and so on. So we fill out the table like that. She can only, if we want to get exact number of shots, she can only do this number and plus this number. Okay. So if we go on and take a look at this, I filled out the whole table. So 1 2-pointer and 10 3-pointers was the last one. So let's create an equation for that. So if x is the number of 2-pointers and y is the number of 3-pointers that Emily scored, what would the equation be? So if I say 2 times however many number of 2-pointers there are. So the total points is however the x number of 2-pointers times 2. And the y number of 3-pointers times 3 equals 32. It could be different, right? She could shoot, if she shoots 16 x-pointers, 16 2-pointers, that would be 0 3-pointers. If she shot 1 2-pointer, that would be 10 3-pointers. So these two numbers are different, x and y. Okay? So x and y are different. They don't have to be different, but in this case, they will always be different. So how do we figure it out? So we just substitute the number of points made in 2-pointers, and that gives us the number of points in 3-pointers she made. So for example, if she made 16 points she did 16 two-pointers. She scored 32 points in two-pointers. 32 plus 3 times the number of y, three-pointers, equals 32. I subtract 32 from both sides. 3y equals 0. Divide by 3. That means she made 0 three-pointers. Okay? If she did 13 two-pointers, then I could solve the equation again by saying, right, she did 26 points in two-pointers, right? So this is 26 points, so I'm going to subtract 26 on both sides. So 3 times the number of three-pointers equals 6. Divide by 3 on both sides, and the number of three-pointers she shot was 2. So she made 13 two-pointers, and she made 2 three-pointers to add together to be 32 total points. Okay? All right, so you try it. So if I have an equation x plus y equals 3, what I'm going to do is pick a number for x, substitute in for x, and then solve for y. So if I have a 1 for my x, if I say there's 1 for x, then I'm just going to say 1 plus y equals 3. I'm going to subtract 1 on both sides, then y equals 2. So y is 2. If x is 1, then y is 2. I'm going to pick another number for x. I could pick any number, but I'm going to pick a simple number. If x is 2, then I have 2 plus y equals 3. And then I subtract 2 on both sides, y equals 1. Okay? So take a minute, pause this, and fill out this table, and we will see in just a second. Okay? All right, so if you filled out the table, 1, 2, 3, 4, 5 for x, you had 2, 1, 0, negative 1, negative 2 for y. If I graph those on the coordinate plane, so this is the point 1, 2. So if I go over 1, I go up 2. So this is the first point, 1, 2. X always comes first, and then y second. X is across first, and then up second. So the next coordinate point is x is 2. If I choose a 2 for x, then I get a 1 for y. So that's this point. And the third one, if I choose a 3 for x, I get a 0 for y. If I choose a 4 for x, then I got a negative 1 for y. And if I choose the 5 for x, then I got a negative 2 for y. Okay, so these are the solutions to the equation x plus y equals 3. It's a linear equation, so if I draw a line, it's a straight line going through here. Hi Gus, please stop meowing. All right, so let's take a look at another one. Practice on your own. If I have the equation 2x plus y minus y equals 10, what numbers would I choose for x? And what numbers would I choose for y? Okay, and then graph it. All right, so I chose a 1 for x. So 2 times 1 minus y equals 10. Subtract 2 from both sides. Negative y equals 8, multiplied by negative 1 on both sides, y equals negative 8. So if I choose a 1 for x, I don't have to, but if I choose a 1 for x, I go over 1 and I go down 8. So that'd be 1, negative 8. And if I continue in the same vein and I choose a 2, I get a negative 6. If I choose a 3, I get a negative 4. If I choose a 4, I get a negative 2. And if I choose a 5, I end up with 0 for y. Okay? The answer to this one are all of these numbers, and it's a linear equation because it's graphed in a straight line. Okay. All right. Take a look at the next one. You try it again. So if I have x plus 5y equals negative 21, remember I can choose a number for x and solve for y, or I can choose a number for y and solve for x. What do you think would be easiest? In this case, I'm going to choose a number for y, 1, 2, 3, 4, 5, because if I choose a number for x, then I'm going to be dividing by 5, which is not always an even number. So if I choose 1, 2, 3, 4, 5 for y, then I get these numbers, right? If I choose a 1, that would be 5 times 1. Subtract 5 from both sides, I get a 16. If I choose a 2, that would be 5 times 2 is 10. So I'd be x plus 10 equals 21. Subtract 10 on both sides, x equals 11. And so on and so forth. So if I chose a 1 for y, then I get 16 for x. Notice my x and my y are still x first, y second. So even though I chose 1 and got a 16, when I graph it, I go 16 over and then 1 up. And this would be 11 over and 2 up. 11 over and 2 up. And this would be 6 and 3. So this would be 6 over 3 up. 1 and 4. And this one actually ends up being negative 4 and 5. Okay? So negative 4 over 5 up. I never would have guessed to do a negative 4 for my x as a first number. That's why sometimes it's easier to choose the y. Okay? See one more of these examples. What if I have 2/5 times x? Now if I choose my y, sure, I subtract the y and I have a nice number here, but then I'm going to basically divide by 2/5 or multiply by 5/2. So I don't know if a whole number over here for y is going to work. What do you think would be the best type of numbers to choose? X or y, and what numbers would you choose? Okay. All right. So I have decided to choose multiples of 5 for my x's. Why? Because I'm being multiplied by 2/5. When you multiply by 2/5, you're multiplying by 2 and then dividing by 5. So all of these numbers are going to be divided by 5, so I want a number that's a multiple of 5, right? So 2/5 times 5 is 2 times 5 divided by 5. They cancel out. It's just 2. So 10 times 2/5 would be 2 times 10 is 20 divided by 5 equals 4. 15 times 2/5 would be 15 times 2 is 30 divided by 5, which is 6. So on and so forth. And then I'm going to subtract those from 11 to get my answer. So I'm choosing multiples of 5 to get through here, and my answers end up being, so this one here is 5 and 9. Let me get my pen out. So notice how 5 isn't here, so it's right between. So this is 5 and 9. This one is 10, and in between 6 and 8, so 10 and 7. This one is 15, and halfway between 4 and 6, which is 5. And this one is 20 and 3. and this one is 25 and 1. So 25 and 1, 20 and 3, 15 and 5, 10 and 7, 5 and 9. So all we're doing is choosing a number that makes solving this equation easy to do. And it works with word problems too. So at the store, you buy a bag of candy for $2 and a drink for $1. Assume you have a total of $35 to spend. You are feeling generous and want to buy some snacks for your friends. Write an equation in standard form that represents the number of bags of candy and the number of drinks, right? So a bag of candy is $2. So a bag of candy is $2 and a drink is $1. So if this is bags of candy and this is drinks, then it would be 2 times x plus the y equals $35. Okay? Does that sound good to you? $2 for each bag of candy plus $1 for each drink, and the total I'm going to spend is $35. There we go. And now I'm going to choose a number for, in this case, x, and y is going to equal whatever that is. I choose a number for x because I don't have a coefficient for y, so it'll be easiest to solve because all I do is multiply these two numbers and then subtract. 4 times 2 is 8. 35 minus 8 is 27. 5 times 2 is 10. 35 minus 10 is 25, etc. Then I go ahead and graph these. Bags of candy is on the bottom and drinks are going up the top. So if I buy 15 bags of candy, I drink 5 bags of pop. Or if I buy 10 bags of candy, I drink 15 pop, etc., etc. But notice, again, it's still a straight line. Okay? So your homework, go ahead and do your homework. Lesson 12, linear equations in 2 variables. Students use a table to find solutions to a given linear equation, and then we plot those solutions on a coordinate plane. So remember, on an equation with 2 variables, the answer is not just one number, it's a coordinate pair, and we can graph those on an equation, and all of those answers are the solution. Okay? So in a linear equation with 2 variables, x and y, the standard form is a number times x plus a number times y equals the constant. A and b are not 0. That gives us a diagonal line. Solution to a linear equation in 2 variables is all of the x and y's that make the equation 2, because sometimes there can be more than one. Like our example when she was shooting 2-pointers and 3-pointers and scored 32 points in a game.